Hi there, welcome to www.highschoolmaths.co.uk. Today we're going to take a look at scatter graphs. So a scatter graph is another type of mathematical diagram that's used to record information or display information. And what you can see here from the example we've got is that the data you're given or the data you have, it doesn't follow an exact pattern. It's a little bit scattered. And this is very typical of real life measurements. For example, an experiment in a science class or measuring and taking readings from somewhere outside, maybe geography or something along those lines. And then you would plot the data on a graph, and it wouldn't make an exact perfect straight line or an exact perfect curve. You have what you end up with is a scatter graph, a group of points that are scattered, although probably have some kind of correlation to them. So here we're looking at just a basic scatter graph of age versus weight, and you've got the two axes, the bottom one, the x-axis labeled in years, and the y-axis labeled in weight in kilograms. So we're just asking some basic questions here based on your interpretation of the graph. So first of all, who is the youngest? So we're looking at for the youngest, we're looking at the x-axis. We're looking to see where the lowest value is on the x-axis for one of our crosses, and that's actually the 4 years old here. So you can see the lowest value for any of these crosses, and on the x-axis is 4. So the youngest would be 4 years old. Okay. The oldest would be the opposite side. So we're looking around here. Now be careful when you're reading your graph. Make sure you're manipulating your axis properly. It's not going up in ones, it's going up in twos, maybe going up in 5s, 10s, 7s, whatever. It really depends on what suits the graph. Okay, so it's 2, 4, 6, 8, 10, blah, blah, blah. So this would be 18. So the old person would be 18 years. All right, the lightest person. So now we're talking about weight. So we're going the vertical, the y-axis, and the youngest person, sorry, the lightest person would be this cross here. That's the lowest one down. So that's also that's us using this cross again. Now, with this one, you're thinking, okay, it's again the axis. Make sure you're really careful. This is 10, 15, 20. It's going up in 5s on the y-axis. So here, if we look at this, I think it's a little bit above the halfway point. So if this is 15 in the middle, then I would say that's maybe 13. And you're using a little bit of an estimation there. A bit of an educated guess using your scale and what knowledge you have. The heaviest would be the highest up. So that looks to be exactly on 48.5 kilograms. Okay. So let's look at this. Draw a line of best fit. So this is the next kind of common thing that comes up with scatter graphs. And when you go into straight line, you'll see that it's really important that you have a nice accurate straight line that follows some rules. Now, it is going to be an estimate. So let's have a look at how this is going to work. So here, we're not doing dot to dot with the line of best fit. Okay, so with a scatter graph, we're not going here to here, here to here, here to here, here to here, and joining it up as we go along. That's not the goal. Okay, we're looking for a line that kind of describes the trend. Okay, so we're looking. The goal is to try and get the line going through as many points as possible, while keeping the same amount of points or coordinates that you've got, crosses that you've got here, above and below. Okay, so we want an equal amount of crosses above and below, and we want a line to go through as many of the points as we can. It doesn't have to cut through 0, 0. Okay, it can cut anywhere on the x or y axis, depending on the slope of the graph. But it has to go through as many points that we've got in this diagram as possible and keep us the same amount above and below. Okay, so if I was to do something like this, you can kind of see that that's going through those 3 points there, but we've got only 1 point above and 1, 2, 3, 4, 5, 6 points below. Now that's not an even balance. That's not going to be an appropriate line of best fit for this graph. So what we're looking to do is get that line a little bit more sloped. So we'll maybe take it and go maybe somewhere like that. And you can, obviously, if you use a ruler, you can just adapt your ruler. Let's say we take that, maybe move it down a little. How does that look? Okay, so we're going through 1, 2, 3. We're really close to 4, 5. We've got 1, 2 points above, 1, 2, 3, 4 points below. So there's perhaps a little movement we could do here, a little bit better. So we can go through 3 points, but that's moving a lot. So there is a little bit of trial and error, and because of that, as long as you draw a line that's valid, that will be fine. So you can see here, we've kind of got 1, 2, 3 points above, 1, 2, 3, 4 points below, and 1. These two are really close, but 2 points cutting through the line, but the points are all really close to the line, and the line looks like it's a fair representation of the data. It's kind of following the pattern of the majority of the data. So that would be an appropriate line of best fit. Yours might be slightly different, but it can't be like the first one we showed, where there was only 1 above and 4 below, and it wasn't balanced, it wasn't following the trend of the data. Okay. Question C, what type of correlation does this have? Okay, so there's a few different types of correlation. There's positive or negative. So positive means your line is going from left to right, going up. Okay, so this would be a positive correlation because it's going up from left to right. If it was going down, it'd be a negative correlation. Right. There's also, is it a strong or a weak correlation? So for that one, you're looking to see, are the points all fairly close to the line, or are they kind of scattered far away from the line? Now, I'd say here, most of our points, apart from like this one here at the top, most of our points are fairly close to the line. So we're looking at a strong positive correlation. The opposite to that would be if the points were kind of further away from the line all the way along, then you would have maybe a weaker but still positive correlation. Okay, so this is a strong positive correlation. Oh, missed an eye. There we go. Okay, and the final part, we're going to use the information on the graph, and you can use the information on the graph in a variety of different ways. It's really, the key thing is that you can read the graph accurately. So, question D, use the line to estimate the weight of someone who's 17. Okay, so for 17 years old, that would be around about here. Remember, this is 18. So for 17 years old, we're looking about this place here. What we're going to do is we're going to take a straight line or your ruler and measure straight up. We're going to go straight up. Oh no, it's not a straight line. Let's try that again. So I'm going to go straight up using the straight line tool until we reach the line, which is there. And we'll go across like that. So we're going to the straight line. We don't have across that data, that's fine. The straight line is our kind of guidance for the average of all these points. This is what we're looking at as a good indication of what the average value would be. Okay, so here, if they're 17 years old, we're looking at around about, I would say just below 40, so maybe 39, possibly 40, depending on looking at the scale, but we'll say 39 years old here. Okay, so we're talking about potentially 39 years old. Okay, there's lots of different information you can use and extract from scatter graphs. When you progress on to more work on straight line, you can start to find the relationship between the x and the y-axis and do lots of more complex calculations with that information. So they're a really important part of your maths, but also other subjects because of the information that can be extracted from them. Hopefully you found that a useful little guide to scatter graphs. There's hopefully nothing too scary there. For more statistics videos and more resources for other topics, please visit www.highschoolmaths.co.uk. And if you did like the video, don't forget to click that like button and subscribe. And remember and share the video. Thanks for watching and have a mathemagical day.